So, hi everyone, let's jump into containers to Kubernetes operators. And I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. My official title is developer advocate, so I mostly speak or try to speak about the good stuff that we do. Maybe you're using our stack already for logging, full text search, metrics, tracing. We have a lot of use cases. This is part of our stack, but I don't really want to dive too much into our own stack today. I will use it a bit as an example of what we do, but it's more about the general idea of what you do with data stores and containers, and then moving them from plain Docker images to orchestration as well. But we'll start with some Docker images, ideas or best practices, especially around data stores, and then we'll move into higher level services, basically. So, starting with Docker, this is the official Docker logo, but I think the right one would actually be this one. And this is, by the way, also the size of your average Docker container, or at least that feels like it oftentimes. So we'll talk a bit about the best practices around Docker containers here. Internally at Elastic, we have this saying that Docker is the world's most heavily funded college project, or actually we had that a couple of years ago. When the APIs were breaking quite frequently and stuff was less stable than it is today. I think things have improved a bit over time, but you still can have fun with Docker. Especially people who don't really know Linux that well will always bump into weird issues. And then you have to explain like, okay, this is what is happening in the background and this is why this is important or why permissions are a thing. But let's jump into those. We see Docker images pretty much as the new zip format, like previously, like 10 years ago. So the way you would consume software oftentimes was you would download a zip. The way you consume software now is oftentimes you download or pull a Docker image. And we're just tying into that. And by the way, we don't really have strong feelings around that. There are many ways to install our software or other pieces of software. And we would never say that, oh, you must use containers and this is the only right thing to do. It's much more about like what fits your use case and what are you used to. So if you do run everything on containers, do that. We're happy to support that. If you don't use containers for other stuff, probably don't start with your data store because that might be getting slightly painful. So obviously this is not without issues. One of the first things that you run into, or at least we run into every now and then, is that people kind of forget security best practices and want to run everything as root and don't care about file permissions anymore, because why would they? And the argument we hear sometimes is like, well, it's in a container, so I don't really care about it anymore. And I think the proper image for this one is this here, and you just have to replace the snake with a whale. And then this is pretty much what you end up with, what some people try to do around Docker. I'm not pointing fingers, but people might see that in themselves or others. For example, Elasticsearch does not run as root because a server process just should not run as root, and it's a bad practice and we don't support that. So we require a specific user and group ID to run the service. And that will also like your files will need to have the right permissions to actually write your data there. And what that kept causing was that every now and then people would open a bug report and then you would have something like this. And this is one of our least favorite phrases, I guess. I prefer simplify and forget Docker containers. And to be honest, what we always imagine when somebody says that is something like, you will run it like this. So this might be nice for testing and development, but we build our images and containers generally for production. And yes, it might take a bit more pain upfront, but we would rather have best practices upfront than a bit more suffering there than losing data in production or having trouble down the road, because then people will come to us, complain a lot, and we're always like, yeah, this is not working as it should be. So don't do that. Another thing that we see quite frequently is that people want to do some host mutation. And again, Unix comes back to you. If you don't know what you're doing there, you're going to reinvent it poorly. And that is very true for Docker as well. So one of the things then that we also see is that lots of people want to run not only their own containers, but especially external dependencies as latest, which we think is a pretty terrible idea. But some people really want to do that. And unfortunately, Docker Hub, this is a screenshot from Docker Hub, is kind of promoting that, because what you do here is if you do docker pull Elasticsearch, you implicitly run this with latest. So you will get whatever the latest version is. By the way, does anybody know what happens if you try to run that with our images? This will actually fail because we don't have latest, because we think it's a bad idea, something that you will regret in production later on. So we don't have latest as a tag intentionally, and people will come to us and complain about it or open an issue every now and then to say like, you're missing latest. And we're like, no, this is not an omission. This is intentional. We don't have latest. Because the thing why we don't have latest is, let's assume you start a 3-node cluster today and you use latest and you will get 7.71. And let's say a year down the road, you want to add more capacity. So you add 2 more nodes and then you use latest again. And then in a year, potentially we have a new major version with breaking changes. And then you might have a terrible day breaking your cluster because you were just implicitly using latest and didn't think about that. So we will actually force you to pick a version number explicitly today, so that when you add more capacity, you will add the same version number and not break your cluster in an unexpected way, and then need support or complain loudly. So that's why we don't support that. Sometimes people say, okay, breaking changes should only happen in one major version number. Do you support something like pinning something to the major version number, or maybe the minor version number? Unfortunately, the way Elasticsearch, for example, works is that some data created with a newer version, even within a minor version, couldn't move to a node with an older version. So it might create imbalanced clusters, which is also tricky to debug then. So we also don't support that. So you will need to specify the version number down to the patch level when you create the cluster. And when you upgrade it, you need to specify the exact version number again, just to avoid imbalanced clusters or broken clusters later on. Another thing that people want to do every now and then is runtime mutation. So something like this, they provide a shell script and then you just run that every time you start the host. Or you provide an environment variable and something gets installed on your container, which is, again, pretty terrible idea. If you've used Docker for any amount of time, obviously the right thing would be you have a custom Docker file, you build on top of our images potentially, and that then, I don't know, add whatever plugins or other things you want to add. And then you push that into a registry and then everything pulls down the same image. Because let's assume this shell script goes wrong on one node and it works on 2 other nodes because, I don't know, you have some error in the network, for example. Then you will have different Docker containers and they might store your data differently. And you might have very broken data because of that, because you might just miss one plugin. And without the plugin, your data couldn't be stored correctly on just one node while it works on others. Again, not fun to debug, and it's just not in the right spirit of containers. So you wouldn't want to do that. So just push that. The one exception where you don't want to bake everything into the image is anything around security. For example, any credentials, key stores, TLS certificates, those you probably want to mount because they potentially have a different life cycle. Like you don't want to replace your containers just because your TLS certificate is ending now. So those should not be baked into the image because you don't want to rotate your images because of that. But otherwise, anything that can be baked into an image should be, and you don't want to mutate when you start up. Another thing that sometimes people feel very strongly about are base images. We have currently standardized on Centos, which is not the slimmest choice, but it's pretty widely used, especially in the US, and also very well accepted by the enterprise. What it kind of gives us, because initially we tried different base images for different products, and then Elasticsearch was running on Alpine and Logstash was running on Ubuntu, and it just caused confusion and different tooling. So we want to have like a similar setup. And also the nice thing is if everything uses the same base layer, even if the base layer is larger, it will be shared across all the products. So you still have to only pull it once on every machine. So then it doesn't weigh in that much anymore. Similarly, once you need the JVM like we do for Elasticsearch, for example, your tiny base image will not be that tiny anymore. Like even if the base image is only 5 megabytes, then you add 150 megabytes or so of the JVM, and then the base image probably is less relevant. Also, With Alpine and MuCL, initially we had quite a few bugs that we ran into. glibc might be old and ugly, but it's very well battle tested. And we kind of like the battle tested nature, again, in the sense of running well in production. The one main downside is size. So where we are kind of careful is that we totally understand if you have a stateless application that you deploy 50 times a day, potentially you care about the size a lot. But with a data store, like the base image might be, I don't know, a couple of 100 megabytes, but then you put gigabytes or even terabytes of data on top of that. So there the size is not that relevant. Also, you won't deploy Elasticsearch 20 times a day. We only release every couple of weeks, basically. So it's not, neither on your network nor on the storage is as big of a burden as with anything stateless. For stateless images, I totally understand that size is an issue, but we're not as sure around stateful stuff that keeps a lot of data. One of the main downsides we have right now is bigger base images, more dependencies. Security scanners will find more things that they will complain about, which creates a lot of work. So we are trying to figure out how either we start from scratch images or slim down the images or pick a different base image. But they all have a lot of trade-offs in terms of size and work for us and consistency. So we'll see where we will end up with that. We're always happy to hear opinions about that because I know that base images are something that people have strong opinions about. Okay, now jumping over to Kubernetes. I guess most of you are using Kubernetes. The battle for that, like Mesos or Swarm or whatever, is pretty much over. To the point that oftentimes we see that people say like, okay, the answer is Kubernetes. What was actually a question? That's, I guess, just a place where we're at, and we're happy to run with that. I think everybody knows what Kubernetes is. So you have your static configuration that you deploy to Kubernetes resources, and the architecture diagram looks something like this, but you have all seen this plenty of times. So I don't want to go through that. What do you get lots of with that? It's normally YAML, and really lots and lots and lots of YAML. So YAML and me are not always best friends, and I always think that people saying like, oh, I love writing YAML, it's kind of like the Stockholm syndrome. So you got so used to writing all the YAML that at some point you just accept it and start liking it. But I'm not so sure. Does anybody know, and this is, by the way, an example from the Docker documentation. Does anybody know what is going wrong here if you run this through a YAML linter? And let me quickly open the chat if anybody has a comment on that. Any guesses what is going wrong here? So I can show you the result of what you will get when you run this through a YAML linter. So port 80 still correctly maps to port 80, but this one here is not, because the problem, if you have this notation here and the value lower than 60, if I remember correctly, then this will be interpreted as the base if you don't quote it as a string. And this is why you will end up with this weird number, and you will not be able to actually map port 20 to port 20. And as I said, this is part of the Docker docs. So this is one of many ways how you can fail miserably with YAML. Or you have a list of countries and it works well for Great Britain and Germany and France until you come to Norway, which is NO, and that is one, I think, of the 13 ways to have a truthy or falsy value in YAML, and that will not work as you expected unless you quote that correctly. Anyway, so speaking about Kubernetes, for us, we had one issue that until 1.8, which admittedly was a long time ago, it did not allow dots in environment variables, which we rely on pretty heavily. Since that was fixed, you can run Elasticsearch on Kubernetes quite easily, which leads us to Helm charts, because probably you don't want to run or start from scratch there. So Helm, I would always describe it like a package manager. So you have a template where you can specify what do I want to have, and then we will just run that in the background for you from that template. So it's basically building on the existing Kubernetes primitives that you're used to. So we have a StatefulSet to store our data, we have a service, we have a deployment, all the things that you know already, we will just package into a template and then you can run that. We have official Helm charts, for example. that support a wide variety of our products, and you can just run them to install them. And what that looks like is, and I'll get into the code sample in a moment, this is normally backed by a stateful set. So the nice thing is you can just reattach that to a new pod, and then you keep your data and you can just do an easy rolling upgrade. And you basically, if you would extend your cluster, you would just add more resources. If you would upgrade a cluster, you would replace one node at a time, wait until the cluster is in a stable state again, and then go to the next node until you are done with all of them. So this works pretty easily. We do support or mainly test this on Google Cloud, but it does work on others as well. The nice thing about Helm charts is generally that they're very unopinionated. So you just use environment variables, you mount your secrets. It's pretty similar in terms of like concepts of what you get from plain Docker images. Just having that templating around and taking some of the work for you away. And there are normally multiple approaches to run this. So if you want to set up security or how you want to set up security is totally up to you, since it's basically just templating around the Docker images that we provide. Here, this would be a very simple example to run this on Minikube, though I won't show you because Zoom screen sharing and Minikube don't play well, at least on my machine. So you can get or add the Helm charts. You can say like, okay, I want to pick this specific version here that I want to run. On Minikube, you need to add some storage providers, which you wouldn't need to do on Google Cloud. And then the template that you could run is this here, for example. So by default, for example, we would try to not put this multiple Elasticsearch nodes on the same host, just in case one goes down, that only one instance is impacted. If you run this on Minikube, you don't want to have this affinity rule, and then you would need to set that to soft. And then you could just set some limits, like how much heap do you want to give to the instance, how much memory and CPU, how much disk, and that's pretty much it, what you would need to do to run your Elasticsearch cluster then. Which leads us to operator frameworks. Operators are very popular because they're like batteries included. They have a bit more power to them, but also complexity. Though the idea is that we take the complexity and do that for you, and then you just build on top of those batteries. So for example, the Helm charts are a one-person project, or it's not even one person working full-time on them, I think. Whereas the operator is a 5 or 7 person team working full-time just on the operator. And what it does is expands the Kubernetes interfaces and allows you to customize the management of applications. And what you have is you have a so-called custom resource definition CRD. And now, rather than thinking in terms of Kubernetes terms like pods and services, you can think of in terms of like Elasticsearch, Kibana, or APM services. So it's kind of like, it has its own namespace, it has its own service, so it's abstracting a bit higher away from that. One thing where I'm sometimes also inexact in terminology, you have custom resources, which are like the instances, like an object in object-oriented programming, and the custom resource definition is like the class. So that's the type definition, or one is the instance and the other one is the schema, or I don't know how you want to call it. But this is like how custom resource and custom resource definition tie together. And sometimes people will say CRD when they mean CR, but normally you get it out of the context what you mean. And you take these custom resources and then you bring them to life with a so-called controller or a custom controller, which is basically a piece of software that runs in a continuous loop and just always checks, you have configured your cluster to be in this state. Is it still in that state? No, then apply those changes and move it forward. Whereas I said that Helm charts, those are like a package manager. The package manager, you tell, install 3 Elasticsearch nodes in this version. Once it's done, it's done. It will not check later on, are still 3 nodes running? While the operator will continuously check in that loop, are there still 3 nodes? No, you have configured 3 nodes. Okay, then I will stand up another node because you lost a node. So it will always make sure you're in that state where you're running. Also that loop, even if you have a bug and it crashes, it will just restart later on. And it is batteries included, so it will do a lot of stuff for you automatically. So it will set up certificates, like custom generated certificates, but it will generate certificates for you for TLS. It will ensure that security is enabled. So while Helm charts give you more choices to run stuff, The operator is more opinionated, so it has a special way to run it. Currently, it supports only kind of like the server-side components, and those are the ones that it supports right now. Building that, it's built on Golang. We use Kube Builder to actually interact with the Kubernetes API and customize to generate patches to the custom resources. If you're using a very old Kubernetes version, for example, that doesn't support some features that we use in newer ones, customize would change it so that it would still work on older Kubernetes versions. And this is how it's working. I'm just checking time. Okay. Won't be too long anymore. I'm done in like a couple of slides. So what you do in general is you deploy your operator, and the operator is continuously running here. And then you define, these are the resources that I want to run. So this is an Elasticsearch and Kibana configuration. And then the operator basically continuously checks, okay, what is configured here? Is this what you have running on the right-hand side? If not, how can I move the cluster that is actually running into the configuration that you have configured to have here? And this is basically the idea of how the operator works. And like I said, it's opinionated. It has best practices built in, so it does more work for you. For example, it knows if I want to remove nodes, that it takes or migrates the data off a node before removing a node, or that it does some operational best practices before doing an upgrade, and you don't need to do those yourself because it's kind of built in. And since it's all code that we've written, we will take care of that for you. Though you can still shoot yourself in the foot. For example, if you only configure a single copy of your data and you do a rolling upgrade, at some point you will need to upgrade the node with that single copy of the data. And for that amount of time, that data will not be available. So it's not guaranteed that everything will just magically work. Just beware. To give you a very simple example, this would be again Minikube. What you would need to do is you need to fetch the custom Kubernetes operator. All-in-one is probably the one you want. You could start or see how the operator is starting up, and then you could apply some configuration. And the next 3 slides are just sample configurations of what you could apply then. So for example, here I would say, this is the Elasticsearch version that I want to run. You can also see here that it has an API version. So this is, rather than thinking in Kubernetes terms, like I said, now you think in Elastic terms. So here you have an API version for Elastic with that specific version. And then you just run this Elasticsearch node. So it's a single node with these configurations, and it has a name, Elasticsearch sample. And this is how you would reference it in other services then. So here we would see that would be APM, and it links to that Elasticsearch sample from the previous slide. And the same thing for Kibana. Since those are stateless and don't have any data, APM and Kibana are simpler to run, and we didn't even limit the resources here. And then to run that, you could just check what is running, do port forwarding to Kibana, for example, to access that. And since we generate passwords for you automatically, you would then need to just retrieve those automatically generated passwords and then could log into the resources. But the rest is already happening behind the scenes for you. And whatever you change, you just change it in the YAML file and then run a kube, CTL, kubectl, whatever, apply to roll out those changes. This is pretty widely supported. I think we even support Pivotal Cloud Foundry by now as well. And it is backed by a StatefulSet again to store your data. I will skip some slides for the sake of simplicity. One thing that is kind of interesting, what you might want to keep in mind here though, is there are multiple ways to run these in terms of terms of namespacing. So for example, you could run the operator once in a global namespace, and that would then watch all other namespaces and check like, are there Elastic resources configured anywhere? And what do I need to do here? So you have the operator running once. This will need quite a few permissions as well to check all the other namespaces, but you only have one instance running here because, okay, this will not need that much memory, like, I don't know, 100 megabytes or 200 maybe. So you only have it running once, and then it could control a lot of other resources. You could also do that in single namespaces. So every namespace runs one operator. Be careful if you delete anything in that namespace, don't delete the operator, because then the operator won't run correctly anymore, obviously. Though here you will need fewer permissions, so more resources because you have the operator running multiple times. So you could run multiple versions of the operator in this setup. Maybe you would also want to set up like a mixed mode where one operator manages multiple namespaces, but not all of them or something like that. So this is just a deployment detail afterwards. There are lots of operators out there. If you go to Operator Hub, you will get the full list. This is ever growing. So to wrap up, something that we hear quite often is that containers are disrupting the industry. And sometimes we're not so sure if this is a good thing because it's sometimes associated with downtime as well, where people run containers kind of like the wrong way and then bad stuff happens. The question that we often get is, can I run Elasticsearch on Docker or Kubernetes? And we think that this is the wrong question because yes, you can, but the question that you should be asking is, should I run Elasticsearch on Docker or Kubernetes? And what is the answer to that? Anybody in consulting will know, it depends. Normally it gets very expensive after that. Not this time. So what does it depend on? If you run all your other workloads on Docker or Kubernetes, probably that makes sense. If you just get started with those technologies, maybe don't start with your data stores because those might be a bit trickier to run. Which leads us to the final point here, which I call the Kubernetes Paradox, which we saw before we had the operator. Companies would continuously ask us like, oh, do you have an operator? And if we said like, no, then they said like, well, this is a blocker. We cannot use your software now. And then once we had the operator, we came back to them and said like, well, we have the operator now. So how much of your workload are you actually running on Kubernetes? And then they're like, well, we're just looking into it. And actually we have 2% of our workloads running on Kubernetes and the rest on, I don't know, maybe some host or whatever. So this is the thing that everybody wants to have an operator and it's like a blocker if you don't have it, which doesn't automatically mean that everybody will use your operator. Though we see very good interest and have it deployed at users and customers quite widely already. But it's not like everybody has to run on Kubernetes. It really depends on your situation. I think we've been diving into the Helm charts and operators like unopinionated versus opinionated, batteries included versus more manual work, but more flexibility. So this is kind of the trade-off where you will need to pick what is the right fit for your use case. With that, any questions? And I would head over to the Q&A. If you want to get the slides, and those include a bit more slides than I've shown you as well, I'll just drop the links to the slides in the chat and you can get that from there. Or you can use the QR code.
Perfect, thanks.
Tony, do we have any questions?
Philip, there's one question in there from from Stateful. Yeah, we have one question.
Is it me or is it you?
In the Q&A, but I've got a feeling you've literally just, do you recommend Helm charts?
Sorry, Tony, I think I lost you for a second there.
Yeah,
but,
sorry, I think my internet's,
no
my internet might be playing up right at the end. Glad it's at the end rather than the start, but there's one question in the Q&A, but I've got a feeling you just answered it on your last slide.
Yeah, it really, it comes down to, it depends on what you want to run. So speaking also to the people building those, what they sometimes say is like, if you have like lots of Elasticsearch clusters running and you want to really go really deep, probably use the operator because it gives you some more power. If you have like 20 or 30 or so services running and you want to have like one generic way to run them, maybe the Helm charts are a bit easier because they also are maybe a bit more generic. But it really depends on how you want to roll that out. And for us going forward, at least for now, we will still have both because both have like a valid use case. By the way, sometimes people ask like, do we have Helm charts to roll out the operator? So far we don't, but maybe we will have it. I think part of the problem is that with changing namespaces, that rollout can actually be a bit tricky, if I'm not mistaken, because we have some GitHub issues open for that one.
Okay.